All right, continue our project presentation. Okay, we have got two team remains. After that, I will cover my lecture part because I want to improve the lines coverage in. Also, there will be two more classes before the top. Both uh, classes are on the same day of Tuesday morning. Any question? No. Then we can continue on team six. Team six. 여기들 좀 도와주세요, 이거. 있습니다.
I start. This is Jeong. Today, I'm going to tell you about the underwater data center that our team has named Submarine Data Nexus. As mentioned earlier, why do we need an underwater data center? The rapid advancement of AI, machine learning, and deep learning has led to significant increase in the demand for data centers. These technologies require substantial computational power, making robust infrastructure essential for data storage and processing. Notably, the remaining and inference of AI models demand far more computing resources compared to traditional data processing. As a result, data center capacity and energy consumption are rising swiftly. According to a report by Moody's, expansion of AI is anticipated to significantly increase energy consumption in data centers. With an average annual growth of 23% from 2023 to 2028. In particular, power usage in AI-focused data center is expected to grow by an average of 43% per year. This increase is primarily driven by the substantial computational demands of training AI models, especially those utilizing high-performance GPUs, which consume considerably more power. As you can see from this figure, most of the power used in data center is used for cooling. So research shows that the second leading cause of power breakdown in data center is cooling. Of course, 56% of server is high figure, but this can be seen as due to the large amount of power consumed by the servers themselves. However, additionally, 30% of power breakdown occurring solely due to cooling can be said to be a critical figure in operating the entire system. So we would like to propose a project as follows. Submerged data centers could utilize the cool temperatures, deep sea water, thus reducing the reliance on traditional air conditioning systems by combining wind power generation. liquid hydrogen, and fuel cells. Eco-friendly data center operations are possible. Next, we did some research on current technology. As the Microsoft project not to explore the potential of underwater data centers, on their efficiency and sustainability. The data center used in this project consists of a total of 864 servers, had a capacity of 27.6 terabytes, and consumed a total 240 kilowatts of power. It is said that there were three major advantages when Microsoft took control of the data center, which are follows enhanced reliability of submerged servers due to high purity nitrogen gas injection. Second, the use of seawater as a natural cooling agent allowed the data center to achieve lower energy consumption. Third, the data center also did as an artificial reef, attracting marine life around the structure without long-term detrimental effects. Next, we conducted research of offshore wind power in France. As of January 2024, France has operational offshore wind power, one of 480 megawatts of the coast of Saint-Nazaire, and one of 196 megawatts in Saint-Louis Bay. And small size data center have a power consumption up to 20 megawatts, while mid-size facility can consume between 50 to 70 megawatts, and the larger one can be from 100 to 250 megawatts. Meanwhile, the largest offshore wind power generator have a power generation capacity of well over 500 megawatts. In other words, this figure is sufficient to cover data center power consumption. However, it is expected that quite few problems will arise, which is the heat generated by the data center will affect the biodiversity around it. Second, the intermittent energy supply from offshore wind turbine. Third, maintenance of data center. So we decided the project objective as like this, optimizing a way to integrate data centers with renewable energy and minimizing the effects on marine environment and wildlife. The first way to solve the problem is use liquid hydrogen. The advantage of using liquid hydrogen in the system does not only help with the power supply issues, but also can play a role in minimizing the effects on marine environment and wildlife. In several industries, for instance, steel or semiconductor production, liquid hydrogen is used as a coolant. By reusing the waste heat from hydrogen generating procedures, we can minimize the heat that directly enter the ocean. Next is pure cell. Problem with renewable energy source is the intermittent characteristic of it. As constant power supply is crucial to data centers, this fact is critical. To solve this problem, possible solution can be storing the leftover energy during peak producing periods, and using this when power supply is not enough. One possible way to do this is by storing liquid hydrogen, then using it to operate fuel cells or generators. And next one is dry dock or press chamber. The problem with renewable energy sources is if the data center if the data center is fully integrated with the cooling and energy supply system, taking out of the water will lead to many problems. Because of these dependencies, designing a way for technicians to operate and maintain the data center without needing to remove it from the water is crucial. This could mean creating underwater structures or spaces where personnel can safely access and perform maintenance on the data center. Akin to the underwater facilities like those used in subsea subsoil drilling. Such designs might include pressurized chamber or drive that allow workers to access the equipment directly while keeping it submerged, ensuring that cooling and energy benefits of the underwater environments are maintained while allowing for necessary operations. Okay. So our team pro- so our team plan is like this. First, conduct proposers, background research of current situation, checking feasibility, ideas to solve expected problems. And for midterm, additional research on technical feasibility, calculating a total energy consumption of each system needed, and finalizing ready system configuration. For final, optimizing final target system, a compatibility check with existing offshore wind turbine and simply visualizing systems. And our teams are very for listening.
Right? Thank you. Question from the team. No? Yeah. No? I don't have it. Right? It's good to see that you combine submerged data center together with the renewable energy source. I want to see the next time to follow my guideline how to project PPT. There's a steps I want to see.
Yeah.
Next time, please. All right. Thank you very much. And then we move on to team 7.
자료를 저한테 카톡으로 방금 보내주셨어요.
몰라. 껐는데 나한테 안 보내고 나는 그걸 안 땄어요. 뭘 본다 그러나. 나한테 보내겠다고? 네?
네, 그거 로그인해 주시면 돼요.
아니 다른 방법이 있어.
무슨 말씀으로 로그인?
수업 중에 잠깐 이걸 배워 팀7 어. Yes.
Okay, so group seven's project this year will be on the topic of reducing vibrations in ships. And first of all, what makes ships vibrate in the first place? So ships vibrate for a number of reasons. Obviously, first of all, in the sea, there's turbulence and whatnot. but another major source of vibrations in ships, which cause a lot of discomfort to passengers and can potentially damage many of the like delicate cargo, depending on what the ship is carrying, is just general vibration from machinery. And some of these different vibrations come from the engine, obviously, and then the propulsion systems. For the propulsion systems, it's often because of like the cavitation bubbles that are caused when the turbines rotate. And then you have like different and like things like cranes, right? Because some ships have cranes on them to do various different stuff. So these are all things that cause this vibrations on ships and can cause a lot of discomfort. And this is what we have our project on. Next thing is, why should we reduce ship vibration? As I said, it causes a lot of discomfort to the passenger on ships. Next thing is that it also can cause a lot of structural fatigue and damage over time. With all vibration, it will reduce the life of a lot of machinery on the ship. So special machinery, probably especially like in research boats, right, where they have a lot of like delicate equipment, right? The vibrations will really affect them, and over time will reduce the lifespan of those machinery and also just the general superstructure of the ship. They will be reduced by wear and tear. Um, and some current ways that ships reduce the vibrations are through like the addition of dampening layers. Right? This is one of them, just a picture I could find on the internet. And there is many other things like active mass dampeners where you use like a type of like a heavy mass that like counteracts the vibrations in the ships. Then you have things like magneto-rheological materials. It's just special materials overall. So this one specifically is a type of material that when exposed to certain magnetic and electrical fields, it changes the mechanical properties of it. So once it's controlled, you can easily counteract a lot of the vibrations that come from the ship. And then you have other materials like controlled granular structures, which operate similarly. And these are just a couple of the current ways to reduce the vibrations in chips. This is a picture of a magneto-rheological device. And so the timeline of our project would be that, first of all, we have our proposal, right, that we're doing now. And we will begin researching all the different ways, right? More extensive research on what we've already done. We will conduct more research on the different ways that people reduce vibrations in ships currently. And by the midterm, we will have compared the feasibility of our own ideas against current ideas to see how much they make sense, right? How feasible they are, if it's something that we should follow through with. And by the final, we'll have selected the best of our ideas in order to we have selected the best of our ideas as an approach to solving the issue of vibrations in ships. And to further prove what we did, we will use through analysis, we will use many different key formulas like things such as buoyancy. We'll take into account things like cost factors, and many other important things that make ships work. And we will present all of those stuff here. And we have these two main goals of our project, right? And these two main goals, right? First one is to generate a novel idea. So there's many ideas out there. So our goal is to kind of just add one more idea to that. So we probably will not be able to get any testing done, but our idea is to compare our own ideas versus what's there and seeing how feasible what we have is can work. And then we will prove again the final concept through many sketches and through key formulas. So team members, you have me, who is Lloyd Anthony Blackwood, and I'm in charge of the first presentation and was in charge of the generation of many of the novel ideas we'll be testing in the future. And yes, same Kong, and he'll be in charge of comparing the brainstorming ideas. And then Youngwon Song will be in charge of choosing the best of our ideas. Just some references showing so far what we've done, and that's it. Are there any questions?
All right. Question from other team?
Yes. Thank for the good presentation. I wonder if there are any numerical indicator related to the problem caused by vibration of the ship.
Numerical indicators. We have not done.
Decibel,
No, pardon me?
decibel, sound level.
Oh, we have not considered that as yet, but we'll make sure to include that in our analysis. Any other questions? Thank you for that question.
Yeah. Right. Yeah. There are more sources. Say something like a propeller, induced vibration. Propeller gives you
Yeah.
source of vibration.
When the propeller spins, right, there's cavitation bubbles that are formed, right, and then a lot of ships currently they either what I was reading is that a lot of people either try and reduce the amount of cavitation bubbles or use them constructively for the ship.
Also, there are other sources, something like wave. Wave also induces vibration. So we need to survey more on the source of vibrations.
Okay.
And also the measures, the treatment, how to reduce. You can classify. You already show us several, 5 of them already. How to reduce.
Oh yes.
In your presentation. I propose to classify them into passive ones and active ones.
Yes.
In the latest stage.
From the research, they were actually already classified, but I just wanted to bring a few of the cool ones that I saw just to show everyone.
All right. Thank you very much.
Thank you.
It's good to have your presentation very short. Only 23 minutes. Okay. So that is good. But for your professional work, you should try to make them as close to the given time. 5 minutes, 5 minutes. 10 minutes, 10 minutes. 1 hour, 1 hour. The exact timing is important for your professional career next time. So try to match time, including your discussion, lecturing, and presentation. And I have several notes on all the proposals. Topics are good to me. So I like your topics, selected one. So please go ahead. But as I give you a guideline using the how-to project, one important thing is you cannot make it out as you present today. Your goal is too big. All the teams. That's why I propose you to make a 2-stage goal. One is a minimum goal, which must be finished by the end of the semester. Show me. No team showed me the 2-stage goals. And second stage can be additional goals. You can do whatever you can. But minimum should be met. Otherwise, you cannot get credit from it, right? So read again your how to project material and presentation about presentation. You see, Lloyd made a good presentation, right? But six, he read manuscripts. I don't like manuscript reading. So next time, this time there will be no penalty, but next time you will get penalty if you read manuscript, right? Problem is most of the reading manuscript is very fast reading, fast reading. So that listeners cannot follow your speech because it's too fast and your English maybe not so good, right? And also the content is very new and difficult to understand. The technological things are inside. So you need to be very slow and this see eye contact with the listeners, audience, whether they are understanding my speech or not. So team 5 on Tuesday, they blocked to read the manuscript, even though he prepared the manuscript, right? So I know that he was very upset. I mean, trying to speak without manuscript. But it was good for me, better than reading manuscript. And also, it is only less than today, the speech is only 5 minutes or less than 5 minutes, right? So you are very bright. You can memorize 10 minutes speech, even though you have a manuscript. Why don't you memorize? But memorize is also not good. But because there is a hint in the PPT, you can remember what to do to speak slowly. You don't need to speak all the materials. But delivering, understanding of audience is much better, important than sending out. Sending out. Final comment is the material can be updated by midnight today and submitted through email or call. Then 3 of us will start evaluation. Because today's presentation is better because they heard about Tuesday's presentation. Right? Also, I see that two teams have a similar topic. So it's okay. But you can update as much as you can do by midnight today and send to us first. Okay. That's it from me. Then because we have enough time, so we can do the discussion session today too, after my lecture. So I hope 장강민, I mean, we heard for discussion.
So then can I bring my USB mic?
What is the material? It can never just break. 2 minutes. Well, it's fine. So this is about the lines correspond surface design. So fairing is make a surface very smoother surface. So it is not to make a abrupt change in curvature. So manually, when you draw, when I was a student, I drawing for surface design, lines drawing as a class for the manual, right? Adjusting the three major lines, the top view, front view, side view. Right? That is together is a line, right? But there's a discrepancy between those corners, crossing point, until their intersections. I agree. That's what I mean. Right? But now you don't worry about this because good CAD systems, but you need to know about the mathematics behind the surface area. And one of the tool or method or theory they are using is a non-uniform rational B-spline surface. The equation is very complex. It is popular and expected. How many of you have your own car? 3 of you? You have a car? 4? Right. How many of you have a driving license? Oh, so right. When you have your car, the reflection of light or sunshine reflected on the surface of the car. When you see the car or selecting a car, it is important property how well the reflection comes from the surface. Right? If surface is not smooth, the reflection of light is ugly, right? As a mirror, like a mirror. The same story. Freeform surface, varying curvature. So when I was a student, I used these kind of tools to draw lines. Suppose this is a structure surface, structure, body of the person. It is very complex, freeform surface, structured surface. You need to have a very different tools, many kind. To figure out, draw out the lines. And also the plastic button, plastic strip. And then the plastic strip has a flexibility, but not so flexible, so that you need to have a weight to push them close down to make my own want-to-be curved strip. And then I use a pencil to draw the one line. That's the way I did when I was student. So it's not simple. Huh? Also, after that, the broad design lines should have met the functional requirements: speed, stability, and motion in the range. So this is my design, right, of the surface. So it's a very complete and locally. And this is a well-known campus name from TU Berlin, Technical University Berlin, provide sure. And then so porcupine is made for handling the curvature or top. So you see, it's not easy to see what is the shape or curvature over there, but the porcupine, the arrows show us the size of curvature there. So easy to see, and also see that whether the curvature is smooth, not abrupt. Sometimes it's not. It is looks like this one. Only seeing the curve, you cannot see the abrupt change of curvature. But there is a jump also in that. One example is this one. This rounded corner sphere. You see that the corner is made of circle, portion of circles, right? And the other one is a straight line. So when you circle and straight line is meeting, the curvature changes big. Zero and some value. Jump from curvature like this. Like this. It's very smooth, right? Smooth. It looks like a smooth one, but it's not smooth. For the say the reflection of light on your car surface, smooth curvature is important for the one, not only for light reflection, but why engineers are mentioning of the curvature is hydrodynamics. The turbine blade, secondary curvature, curvature secondary of change of curvature secondary. Secondary route is important for engineers, right? And Okay.
Smartphone connected.
Defined by a point and tangent. And point.
Smartphone disconnected.
And by moving or changing numbers of the position and vector, right? We can generate different curves. That is it. Right? Verify.
안녕하세요. 미카 의심리 상대.
Right. And then they develop another way of Bezier. Bezier is a personal name from France. Not Bruno. What is the name of car maker? Bruno. Pujo. Pujo. I remember Bezier was engineer. And he developed another way of generating curves and surfaces. Here he developed a way of using control. So 2 point is okay, and then 3 point, 3 control point, and 4 control point, and then 5 control. By mixing somehow well, or so how can I say? Mixing those, say 4 points, weighting parameter at each of them, and then and another way of combining them together, we can generate this. So, here is moving on this way. So, right, this way. Okay. See that you are interpolation of interpolation. Right? 2 points are moving. 2 points are moving. See, from here to here, the other point is moving from here, and then the green has also another point is moving on the green line, and that generates. This one is once again one more level, right? Point is moving, and then green line is also moving, and finally the blue line, right? So it's a layer and interpolation. It's simple, right? But you should very good. Only providing points. Better than providing the tangent vector. Tangent vector is not easy, not intuitive. Point also as an engineer or designer, you just change the position of point to make different curves. Modify the shape of the curve only by changing the position of and Bezier, and then also basis for B-spline. So equational wise is very layered one, so that looks very complicated, and also calculation is not simple. No, it looks complicated, but computer can do very fast. That's why they say control point, intervals, and interpolation, layers and layers. So finally, they arrive at nerves. So nerves can allow you to easily define or generate a surface like a head going on here.
In this lesson, we will learn about NURBS, objects, and modeling. NURBS stands for Non-Uniform Rational B-Splines. NURBS are useful for very smooth objects or when you need an exact surface. A NURBS object always has 4 sides and is made of mathematically created curves, which are defined by control points. An individual control point does not show where that surface will be, but it is averaged with the surrounding points to create a curved surface. This means we cannot directly edit the surface. If we pull a control point, the surface will only move a little bit because we are averaging the change. To create complex objects using NURBS, we have to create many individual NURBS objects, often called patches. A common issue when working with NURBS is visible seams or breaks in the otherwise smooth surface between patches. But with care and correct workflows, we are able to hide the seams between patches so that this multi-patch object looks like a single surface. These difficulties mean that NURBS are rarely used in the computer graphics world, but it is often used in engineering and product design because of the very precise nature of NURBS. If you need to create a very smooth object or mathematically exact surface, try using NURBS.
And for ladies, there is a word, terminology like word saying patchwork. Have you heard about patchwork? Patchwork is sewing small clothes pieces together to make out of your clothes or blanket or something. Patchwork. Same. Patch. Patches of surface elements. Yeah, but how can you make it smoother? So smoothness, curvature changes between boundary. It is important. Very complicated equations behind there. And then finally we arrive at the complicated ship design softwares. So that without doing your personal drawing or pencils, you can do quickly and better using computers. So parametric modeling of complex shapes. So these are AP. What is AP? What is AP? What is AP? Perpendicular. Perpendicular after 4. Start and then between them is a length. And then some properties. Probably area, sectional area. This is sectional area code. And then this one is what? Position. So by combining these things, you can do yourself tell the computer CAD system to generate the surface. So by giving you this input as an input properties. See, finally the surface, good surface is coming, and complex shapes. You try to make changes of this portion of Earth, purposeful, right? Or to other, but looks very similar, but they are trying to see the small changes like this. Using change of the parameters, design parameters, and parameterization. By changing parameters, the verbs are changing. Looks like a nerve surface corrections. And there's commercial softwares. So most of Korean shipyards, shipbuilding company use software coming from. This one is from UK, I guess. Right, from US, but the company is sold to another company in Norway now. So also Katia is from France. Russell system. And engineer is from Korea. Right. Question? No. We can move on to discussion.
Yeah, space preference is there. So space important topic is performance rise. So P1 is types of work. So first of all, I'm going to explain the definition of work. Um, Power is the main system of ship or boat which floats on the water and pumps in direct contact with it. Significantly influence the vessel size, weight, speed, and stability. So the shape and design of the hull vary depending on the proposal of the vessels and the environment in which it operates. The red line is the hull. So let's discuss about the typical four shapes of hull. Uh, so just discuss slowly. Flat bottom hull.
Flat bottom holes can go through shallow waters.
Actually, impact more coverage in water.
More common.
More.
How about mid beaver? Second one. Mid beaver still is so good. Oh, maybe. How is say really?
I think the multi-hull design will be stable against rolling.
Oh, that bottom for this. I think cost effective because the construction process is simple, but limitation that are is low speed. With the bigger brands are so similar with your measure. So for the next phase, so big rule is displacement or just planning work.
So um, ships are can be classified by mainly classified by two types: the displacement curve and planning curve. So their definition and character of this type of curve, you can uh, let's see a short video.
Boats come in a wide variety of shapes and sizes, and so do their hulls. Despite the variety, all hulls are designed to do one of only two things: either displace water or ride on top of it, which is called planing. Sailing boats, slow-moving boats, and large boats like cruise ships have displacement hulls. The combination of their weight and power means they move lower in the water, pushing or displacing water, rather than riding on top of it. Smaller, faster boats, like power boats or personal watercraft, typically have planing hulls. Planing hulls are designed to rise up and ride on top of the water at higher speeds. Now let's look at some specific hull types.
So let's discuss about these four shape of parts. Let's guess which one is planning or displacement first. Let's discuss. Really? Okay. Oh, here is planning more and more pure displacement. Okay. So this is topic just distance of third shapes is that this of this painting or drawing on the blackboard. So, five-star more. So it has a three horse, one main horse and two side horse. So it has good stability and with high speed.
Reason why those like that so is there a reason why those that type of so yeah?
Yeah, yes. Yeah.
Okay.
Yeah.
Okay, now next slide. It's okay. Here. So we are on the track, scheduled track. Next week we will have a fresh start of the regular schedule. What on Tuesday morning and and the midterm exam will be covered up to there. Tuesday next week. Question? I'll show you how to exam old one. Probably I'll send you small one, updated one like because we have time. This is the old one. Probably time. They do open book exam, you can use any material, including notebook, internet, except this question. And usually I provide you many easy problems. You may be run out of time. Time is limited, only within the classroom hours, 75 minutes. No extent. That's why you need to preparation. Reading is the same. There is a mixture of selection problem and writing problem. For the writing problem, you need to concentrate. Exceeding 100 words count is penalty. But incomplete answers, even though you don't know the right answer, it's better to use something to write. Average, old classroom, exam place, exam hour, 7 minutes, and all the exam sheets is available at the website. Not everyone. Some of them. So you see my style. Style is the same. Contents is different. And Google survey will be used. On online, so you can do online exam, but because we did the corona situation, there's our rules, things like this. Okay. Question? No. Yeah. See you on the next week.